Hello friends, welcome to Kion Lab. In this video we are going to see introduction to database. So DBMS, it stands for Database Management System. Data, the first question comes in your mind, what is meant by data? It's a database management system. So basically we are going to manage the data. One system is there which has a hell lot of data, and that we are going to manage. So data can be anything which can describe the people, or it can be information about something, it can be a knowledge. Information, knowledge. So data, if we want to represent and we want to store and we want to retrieve, then we require some system to hold all this information, and if required we can retrieve that. In old days everything was on the black and white, that is on the paper. So after a long decade it can vanish, or we could not get the whatever the required information we want. So that's what this database management systems comes into the picture, where we have interrelated data. So example, we can talk about a student and the courses he can apply it for. So student, it can have his information, he can have the name, he can have the address and the details, and in the courses he can have what course he is going to apply it for and the details about the courses. So this data we are trying to interrelate, that is a particular student which course he has applied for. So this is the relation we are trying to make, and what a student has gone for, which how many courses, that detailed information or interrelated information we are going to store. So that system allows us to store the data. So database, in this slide or in this video we are going to see today only a purpose of database management system. So database, what is a data? So it is a technical information you can get here, that is data is information that has been translated into a form that is more convenient to move or process. So it contains information about the particular enterprise. So I already told you it can be any system where there are many things comes into the picture and those are interrelated. So that can be a database management system, or moreover technical term, you can see here this definition. DBMS is a computer software. It is nothing but a program that allows users and other software to store and retrieve data in a structured way. We are talking about here in a structured way, because here in the earlier slide we have seen here the example student and courses. So student, you have name, address, so it has a fixed structure. Name, it can have fixed structure, it can have its length in the string format, alphanumeric, or whatever we have already mentioned over here. So that is a structure. Course ID, we can have alphanumeric information. So that's what this definition is more related, that is DBMS is a computer software that allows users and other software to store and retrieve data in a structured way. So the more technical definition you can observe here, a DBMS, database management system, is a complex set of software programs that controls the organization, storage, management and retrieval of data in the database. So you can have here the storage. So you can have large number of storage, then you can have, you are going to manage that data. So as the new student come or new customer comes into the bank, we can manage that. That means we can add that customer to the bank. If somebody left the bank, somebody left the school, somebody left the college, we are supposed to delete that information, or in any cases we can delete the information. Retrieval of data, at any circumstances we would like to get some analysis about the data, we are supposed to retrieve the data from the database. Now here some of the applications you can observe: banking, airlines, university, credit card transactions, sales, telecommunication, online retailer, and many more. So in any application where the huge data involves, their database management system comes into picture. Now here today's ultimate aim is the purpose of database system that we are going to see. Now typically file processing system is supported by a conventional operating system. In the old days, database application were built directly on the top of the flat file systems. You might have heard about the file systems in C or C++ where plainly the data gets stored. So they can have the permanent record if any changes, any managing of data or any retrieval of data. Management of data is basically difficult in the flat file system. So we require different applications program. So what does it mean, different applications program? That is, database is stored and we want to perform all these actions on that. That is a storage, retrieval, management. So different program is written. You might have heard you're connecting the database to some of the languages. That is, you can connect Java language with the database. So through that application program we are going to manage all these applications. So to resolve all these drawbacks of file systems over database systems, we can see the drawbacks of the file system for the storage. So first drawback of the file system is data redundancy. Now data redundancy is what? It is the duplications of data. Now here we can see with the example, if we have three fields, or the storage information is something like this: name, ID, and department name. And we have some of the information stored something like this. We may have ID 1001, name we have Kim, department we have physics. Another record we have 1002, then we have the name cats, we have department name biology, and one more record we have 1001, name is Kim and department name is physics. Now here you can observe that duplications of data. So the whole information about the particular ID or a particular student is available twice. Now why it is happened? Because the application program is written and the same program may be handled by multiple programmers. So that's what these duplications may happen. This is what is called as data redundancy, duplications of data. It leads to a higher storage and access cost. So multiple times the data is going to store because of the programmer. So it can create this drawback, that is required higher storage and access cost. And if you are trying to fetch a required data, that is, suppose I would like to access this record 1001, so I will get twice two information. So you can have example, that is savings account and checking account record. Now the second drawback is data inconsistency. Now data inconsistency, the several copies of same data may not agree with each other over a time period. So how it will justified? We can take the same example. You can have ID, you can have name, and you can have department. So we can have the three records 1001, name is Kim, department is physics. One more record we have 1002, we have name cats and department is biology. and one more record we have 1001 Kim and biology. Inconsistency. So inconsistency may not happen over a period of time. So you can observe here this department physics and biology, which is going to differ for the same ID, same student. It cannot be present in the two departments. So this is the second drawback of flat file system, data inconsistency. The third drawback is data isolation. Data are scattered in various files and formats. Writing a new application program is difficult. What it means? So over the period of time, many application programmer has involved in writing the application, data is scattered, and to make any changes or any formatting, one has to write a new program, which is again the difficult one. The next drawback is integrity problem. Now what does you mean by integrity? So you can have here, you can observe here, account balance is greater than 0. So integrity, these are nothing but checks, or you can call it as a constraint. So these are the checks, integrity or constraints. So we are going to apply the checks or constraint on some fields, like some information cannot be a blank. So these are the integrity constraints. So as we are moving forward, we are going to see the integrity constraints in details. So here you can observe your account balance. Account balance is always greater than 0. So this is called as the integrity constraint, that is null value. So account balance cannot be 0. Similarly, account ID, it cannot be null. So these are the null constraint, 0 constraint. So these are we are going to see in details. So you can observe here, data values must satisfy certain types of consistency constraint. Hard to add new constraints or change the existing constraints. So similarly here you can observe account balance, which is greater than 0. So once you have set this constraint, it is difficult to change. The next one is atomicity. Now failures may leave database an inconsistent state with partial updates carried out. Now what do you mean by? The example you can observe here, fund transfer. So you can have fund transfer or you can check the simple example. You are taking out, you are withdrawing the money from ATM, and you press the button withdraw money, and at the same time power goes off. Now many a times you can observe that you will get the message that your money gets withdrawn, but you don't have money in your hand and you might be scared whether I have lost my money or not. So this is what is been called as atomicity, that is it can have either 0 or 1. Means the transaction could happen or it may not happen. It is not like that, it is partially happened. So this is what is called as the atomicity. Transfer of funds, you can see here proper technical thing. Transfer of funds from one account to another should either complete or not happen at all. That is, fund transfer must be atomic. Atomic is the unique value. Next constraint is the concurrent access by multiple users. So this may not happen with the flat file system, or with the old banking system it may not happen. So concurrency is what? Concurrent access needed for performance. Like here you can observe 2 people reading a balance and updating it at the same time. So if it is allowing the concurrency for performance, then person 1 and person 2, they are trying to access the account at the same time. So I have my ATM with me, and my brother knows my account number, so he is doing the online movie ticket booking, and I'm trying to withdraw the money. So two transactions are happening on the same account, so to increase the performance. So this is called as the concurrency, so which may not happen in the old flat file systems. Next drawback is security problem. Hard to provide users access to some. Now there were no security or very less security in the flat file systems, because you're plainly storing the data, ID, name, or whatever the details of the student, customer, or any system you will check, but there is no checks, no constraints. Now here you can observe that we have checks, we have constraints, so we are trying to provide the security more and more. Now these are some of the drawbacks of the flat file system over a database system. So database system helps us to provide the solutions for the above problem. Now in the next, here we can conclude the today's session. What we have discussed today's, that is, first we have discussed the definition of DBMS, that is, it is the interrelated data. Then we have seen the applications of the database management system, and the third one we have seen the drawbacks of the flat file system. Here in this we have discussed data consistency, then integrity constraints, then security, so all these drawbacks we have discussed in the today's session. Any query you have, you can mail us to the kionlab@gmail.com. Thank you.